See, a bullet of mass 10 gram moving horizontally with a velocity 400 meter per second strikes a wooden block of mass 2 kg, which is suspended by a light inextensible string of length 5 meter. Okay. As a result, the center of gravity of the block is found to rise vertical distance 10 centimeter. The speed of the bullet after it emerges out horizontally from the block. Let me student, if I will be observing the case, let this is the bullet and let's the block is this length is students given. Mass of the bullet is 10 gram. It is moving with a velocity of 400 meter per second. Strikes a wooden block of mass 2 kg. This wooden block is having mass 2 kg. And the string length is students 5 meter. Okay. It just penetrates. So when it penetrates, so this was the level of the center of gravity of this. After penetration, what is happening is given. The block is found to rise with a vertical distance of 10 centimeter. That means initially it was like this. Now the block is like this. After the bullet penetrates, and this height, this reference level, and this height is students how much? It is given 10 centimeter. Okay, and after that, the bullet emerges. So we have to find the speed of the bullet. What is the speed of the bullet after it emerges out? We have to find this one. Okay. Student, mass of bullet is 10 gram. If I'll be converting 10 gram, so it will be 10 to the power minus 2 kg. Okay, rest all are here 10 centimeter. If I'll be converting, then it will be how much? And this is 5 meter or 5 centimeter in the question given. String of length 5 meter. It is 5 meter given. And here 10 centimeter. 10 centimeter means if I'll be converting it to meter, then it will be 0.1 meter. Students, let's find the speed of the bullet. We have to find the speed of the bullet after collision. Student, when the speed of the block, what will the speed of the block we have to find first? Let the speed of the block be students v1. Let the speed of the block is after the bullet enters. Students, using conservation of uh, energy, if you'll be going to conservation of energy, then initial kinetic energy plus potential energy will be equal to what is the kinetic energy and potential energy at the final. That means student here, block was at rest. The only energy is due to the bullet. That is how much? Half mass of the bullet into v1 square. Students. Initially, this was having this much mass. This was having this much mass. Then they moved together with some velocity. Friends, they moved with together some velocity. They move on. So we want to find the velocity of this block. We want to find. So if I will take the both mass as m, that will take the both mass. This is 10 and this is it entered with a velocity how much students? This velocity is 400 meter per second. Yes or no? So block, if I'll see initially the block was how much? At rest, and it is going to a certain height h. That means the this rest energy, it was not having any energy, but due to the edge, as the bullet entered, it rose to a height. So at this point, what is the velocity? What is the energy stored in the bullet? That is mgh, h height. And what is the velocity of the? What is the kinetic energy initially from where the bullet is going to get the energy? When the bullet is entering, it is getting some kinetic energy. These are no students. So that the bullet is having some energy, initial energy, that is half m mass of the bullet and v1 square, but that is not going to be useful. Here, when the bullet enters, it moves with a velocity. Yes, so we want to find the speed of the block after collision. Here, what will be the velocity? Means how much it went to this much potential energy. When it entered, what is the kinetic energy? So then if I'll be going for kinetic energy plus potential and will be equal to potential energy, then student here, the kinetic energy I could get as half m v1 square. That will be equal to the potential energy, that is mgh stored in the block. Yes or no? So from there, by solving, I will get v1 is equal to root under 2gh, and it is going to a height 2 into 10 into height is how much, student? 0.1, 10 centimeter ऊपर जा रहा है. So by solving this, I will get it as root 2 meter per second. Understood? Then for finding the velocity of the bullet, we have to go for what? Conservation of linear momentum. Student, block and bullet system तीनों को दो को एक ही system मान के चलो. So using conservation of linear momentum, students, conservation of linear momentum, if I'll be applying, initially this was at rest, that is m into 0, block 2 kg, that is 2 into 0, plus, students, bullet was how, what velocity? What is the momentum? 10 to the minus 2 into 400. Yes or no? That will be equal to common velocity. It moved with the velocity v1 and it moved with the velocity v2. Velocity after collision we want to find. So that is how much? 2 into mv, 2 into velocity of the block is root 2. Just now it derived, plus velocity of bullet. Mass of the bullet is 10 to the minus 2 into, let that mass velocity is v1. We want to find this v, velocity of the bullet. This is the velocity of the bullet after collision. And by solving this, we'll get this is 0, 10 to the minus 2 into 400, and here 2 root 2 plus 10 to the minus 2. If I'll be solving, student, then I'll get v is equal to 4 minus 2 root 2 divided by 0.01. So that is equal to 117.515 meter per second. And near about, if I'll take it, is around coming 120 meter per second approximately. 120 meter per second. This is the required answer to the question. Students, initially they are having no energy. It is having kinetic energy, no potential energy. It is just hanging like this. Initially it was at rest. Right from the ground level. So this is the bullet mass, and this is the block. If I'll be going, it started moving with some velocity because it moved to this side. How? By the enter of the bullet. Let the mass is here combined, mass of the bullet and mass of the block. Both are common bullet system. So initially, so this energy at this point, it is having what energy? Kinetic energy plus potential energy. Yes or no? So that one we're comparing to find what is the velocity after this. What velocity the block is going to get when the bullet emerges out. Okay. What is the energy at this level? What is the energy at this level? It went to a height of 10 meter. Sorry, 10 centimeter. From there, we're finding. Seriously, particle moves at a point from this to this. When a force of 4 I cap plus 3 j cap Newton is applied, how much work is done? But you know, work is equal to force F dot S. So, and here for S, we have to find the position vector when the particle moves from this point to this point. So the position vector we want to find means position vector is, let this is R2 minus R1. So that is equal to how much, students? 4 I cap plus 3 K cap minus 2 I cap plus 5 J cap. By solving this, I will get it how much is 4i minus of minus 2i, that is how much? 6i. R2 minus R1. 4i minus of minus 4i plus 2i, how much? 6i cap plus 3k cap plus 5j minus 5j cap. How much? Minus 2k cap. This is the position vector. And force is given 4I cap plus 3j cap. So Wagner is equal to students. How much? 4I cap plus 3j cap.
So plus 3k minus 5j. So jk only plus 3k plus minus 5j.
अच्छा अच्छा
फिर
अच्छा
आपने
ठीक है
k
ठीक
ही
हाँ okay. So here students, this is 6I cap, but here 3k both are all different. So here I can write plus minus 5j cap, yes or no? Plus 3k cap, correct? 6I cap plus minus 5j cap plus 3k cap, okay? This one we are going to make the dot product. 6I cap minus 5j cap plus 3k cap, isn't it? Students, so multiply this one. 4I cap into 6I cap, how much? 24, yes or no? Then 3 minus 5, how much?
minus 15.
24 minus 15, how much?
9.
So some error is there in the question maybe. So I think this is 2I cap maybe. If this is with 2I cap, then it will be 2I cap. Now how much it is becoming? Oh, this is 2I cap. This is minus symbol is not there. This is 2I cap. So 4 into 2, how much? 8. And here you see 3k cap minus k cap is there. No? This is 4I cap plus 3k cap. Yes. And this is my plus 2I cap plus 5j cap. So that is it will not be 24. We will make it minus. Then it will be 4 into 2, 8. Then it is 3j cap minus 5. How much? 3 into 5 minus 15. 8 minus 15. So let's see. In this way, we'll see the question again. We have to find in this way. 8 minus 15, that is minus 7. The question, but this is the process. You find the first the position vector, then you find the force, given the force 4I cap plus 3j cap. Then you do the dot product. Okay. This is the required thing. 3 minus 5. Students, here 3, this is minus 5 is going to be how much? 3 minus, so this is j cap, students. I think this is j cap, correct? Then only the answer will come. This is j cap. If this will be j cap, then 3j cap minus 5j cap. It is how much? 3 minus 5, 2. This is 2. This will be minus 2 j cap. Okay. Students, 4 to j 8, 3 to j 6. Whatever you go, 8 minus 6, that is 2. 8 and this is 6. Okay. There is a little changes in the printing mistake. So you take it as 2I cap plus 5j cap plus 4I cap plus 3j cap. 4 minus 2, that is 2. 3 minus 5, that is 2. So k cap will not be there. So by solving this, you could get k cap will not be there here in this term. K cap will be not be there. Then if I'll multiply 4 into 2 minus 3 into 2, 6. 8 minus 6, that is equal to 2 joule. Maybe the question. This is the process you just remember. Okay. Friends, a body of mass 1 kg begins to move under the action of time-dependent force. F is equal to 2t I cap plus 3t square j cap Newton. I and j are unit vectors along x and what is the power developed by the force at that time t? Friends, you know, in the question, force is equal to given how much? 2 I cap, sorry, 2t I cap plus 3t square j cap. Correct? Mass is equal to how much given, students? 1 kg. Can I go for acceleration? Acceleration is force by mass. That is equal to, why I'm going to acceleration I will know because I want to find velocity. So that is 2t I cap plus 3t square j cap divided by 1. So that is becoming same. So the acceleration is and also 2t I cap plus 3t square j cap meter per second square is the acceleration. Okay. So it's at time t we want to find the velocity. So velocity is equal to how much? A dt na students. Acceleration integrated with respect to dt. So that is acceleration how much? 2t I cap plus 3t square j cap. Correct. Integrating dt. 2t integration students how much? T square by t integration 2 into t square by 2. 2 cancel plus 3 into t cube by 3. 3 3 cancel. So that is equal to how much? T square I cap plus tq j cap meter per second. This is the velocity after t time. This much meter per second. Friends, you know power developed. You know P is equal to W by T. Na? W is equal to Fs. Fs by T. S by T is how much? Velocity. So power is equal to also F dot V. So if I'll be going for power, then that is equal to F dot V. So that is equal to 2t I cap plus 3t square j cap dot t square I cap plus tq j cap. By multiplying that one, I will get 2t into 2t, 2tq plus 3t square into tq, that is 3t5. This much watt. Got it? 2t square, 2tq plus 3t to 5. This is the answer. Okay.